Ronald. I think we have to move on to the next speaker, which is Dana Kovaleva.
May I ask you please to let me know 5 minutes before my time expires?
Okay.
Thank you.
Yeah. So let me just introduce Dana while she's getting set up there. So Dana is a researcher in the Russian Academy of Sciences in the Institute of Astronomy on stellar systems in the Stellar Systems Physics Department, and is associated to the Center for Astronomical Data Russia in Moscow. Okay, so I give you 5 minutes as you asked.
Thank you.
Please.
I represent here both the Center of Astronomical Data of the Russian Academy of Sciences and the Russian Virtual Observatory. I would like to tell about recent challenges and creation, distribution, and processing of astronomical data we've made in Russia, and about the Russian Virtual Observatory experience in dealing with ground-based astronomical data, and about the different situation with data from space missions. Certainly, as it was discussed today many times, recent decades led to significant progress both in astronomical observations techniques and in IT technologies, which naturally led investigators to a conclusion that they do not need to keep their data for themselves, and that is more reasonable and even more profitable to share them and make data open as much as possible. Simultaneously, we saw how the traditional photoplates and photofilms has become history, and thus a question arises on how this data may be used in the future, while we know that the photoplates are growing older and the information may just extinct. The public acceptance of necessity of data preservation and promotion of open access has been greatly promoted in Russia by the ideas of virtual observatories. The Russian Virtual Observatory was, I'm proud to say, one of member founders of the IVOA, and its purposes were formulated from the very beginning as both to provide the Russian astronomical community with better access and information about world astronomical resources, and to join Russian astronomical data and promote their availability to world astronomical community by integration into the VO. I'm sorry to say that lack of funds did not allow any infrastructural projects joining the RVO. However, it has been a real inspiration that involved many investigators toward seeking funding for the projects leading to make their data more freely available and to create new resources joined by appreciation of your ideas and standards. Since the very beginning of the Russian Virtual Observatory, we've been gathering some statistics about ground-based astronomical data resources in the internet. And I would like to show you some statistics concerning the data resources hosted and maintained by Russian astronomical institutions. These resources contain original data provided by Russian astronomers or created with their significant participation. The statistics for the last 15 years includes mainly scientific data, purely observational as well as value added, and codes for processing and analysis of astronomical data, and educational and popular resources. These two last kinds of resources were very poorly presented in 2002 when it all has started, but they are growing much quicker than scientific data, I would say. So, it is certainly a naive approach to count astronomical data resources by numbers. It's like counting flies, fishes, and elephants all together. However, if you want to know if the life is going to extinct or it is going to bloom, so even counting them by numbers has some sense. So one may see how the number of freely available open data is growing with years. These are the fields to which these data resources are, with which they are dealing. Here, the stripe is a share of these kind of data resources, and blue part of the stripe is the share of regularly updated resources among these topics. While you support such a rather large list of references, you may notice that while you return to it after some time lapse, you do not find some references. Sometimes the problem is occasional, but actually I would say about 5% of data resources per year became inaccessible forever. They stop to be supported, they extinct. And it is sad to say that one of the main causes is the fact that supporting data resources is very underestimated and underfunded work. One more tendency of the recent years is that during few last years, more and more data resources, especially popular resources, are hosted by independent platforms. This makes them free and more flexible from bureaucratic reasons, but I would say that this places them into the risky zone to lose data. I will not specially stress on preservation of photographical observation archives, but I will mention it some later. I would like to talk about some examples of astronomical data resources selected because it is convenient to illustrate some problems and some solutions on their example. The largest observational archive in Russia belongs to the largest observational site, which is a special astrophysical observatory on the North Caucasus. It contains 1.5 terabyte of observational data by now, mainly by the largest 6-meter telescope, and part of data are from radio telescope, Ratan, and smaller telescopes. The histogram below is for the how the archive grows with time, and this circle represents the share of data from different instruments. I would say here is the radio telescope, and here are minor telescopes, and all the other is 6 meters. The general catalog of variable stars is a good example of how the digitizing of astroplates is involved into science and gets funding, because the creators of general catalog of variable stars use the astrophotographs, digitized astrophotographs, to discover new variables. The previous two data resources were created before the virtual observatories and just have improved and grown with time. However, the next three resources are the examples of the resources inspired and using virtual observatory standards and completely interoperable. The situation with data from space missions is quite different. The problem is that historically in Russian Federation there is no institution that would join all scientific information from space missions. Instead, the archives are usually managed and maintained by the institute that had the scientific program of the mission. And so the data policy and implementation of the archive depend on mission and on its purposes. An example of past mission I would like to discuss was an Astron spacecraft. This was the largest ultraviolet space telescope of its time, and I believe few of us even know this name because it was the example of how you should never manage the data, of remarkably bad data management. The data were not the volume of data was not so large. However, even in this situation, astronauts have observed supernova in 1987, and it have observed Halley's comet, and all the data were published in a book in Russian. Thank you, and never digitized until recently, when this work was done, and I was told that very, very soon the catalog will be placed to the CDS. Current mission, Radio Astron, is a space interferometer. The problem is, in spite of the fact that Radio Astron is acting since 2011, you cannot get its data because several experiments are going on and they are not over. And when they are over, after a proprietary period expiration, the data would become open to the community. I don't know, this means that some 7 or 8 years of operation of the spacecraft operation, the data are not available to anybody except the science teams awarded by observant time. The closest future mission, Russian-Germany Spectrum Röntgen Gamma. The launch is scheduled for the next year. It is supposed that it will operate in 2 modes, and one of them is going to become open data at once. It is planned that pointed phase will be open at once, and the all-sky survey will have a proprietary period of 1 or 2 years. It's not settled as far as know. The World Space Observatory Ultraviolet or Space Ultraviolet spacecraft is going to be launched in 4 years. And this is the first Russian space telescope that is planned to make its science archive to be VO compliant. So I have presented a brief review of Russian astronomical data sources, avoiding some areas like sun, solar system, and solar terrestrial data. Basically, we may state that main part of astronomical data from ground-based sources is either integrated into VO or moving toward this integration. However, the situation with data from space missions is different. We work on making the data available to world astronomical community. Thank you very much.
Questions for Dana? One in the back there.
Thank you. I was interested in your statement about spectrum X gamma. You said the data from the pointed phase would become available at once. Could you clarify what that means, please?
This information was given to me by the member of spectrum rentgen gamma key team, Vadim Arefyev, whom I thank here. So I just put it as is. I cannot comment.
Okay. Can I ask my own question, actually? Can you say something more about the scientific school?
This is a kind of financial supporting provided to leading scientists and the astronomers that work together with them. So it's my travel grant, actually. It's
okay.
not a school for the school children.
Okay.
Sorry.
Okay. There's a question by Andy Pollock. And
you mentioned that there wasn't a central body to manage archives. Do you think that would have been a good idea, or would it have been too early in the development of services in the Russian Federation for a central organisation to have existed? I know that's a strange way of asking, but
I believe it would be reasonable to have similar rules and similar standards for space missions. Just looking at the examples of the countries that have scientific space agencies.
it took them a long time to sort themselves out into...
Yes, certainly. So.
okay, two more questions. Okay, down the front first, please.
Maybe I was not following completely, but every few days we follow the data in the gamma ray for GRBs from the group of the former group of Mazet, and
Yes.
there was no mention about, or did you? Because this is something we are following every week. I mean, and there are splendid data coming in.
Yes, it was counted in the within the regularly updated resources. Certainly, gamma ray bursts. Yes.
Okay, I think very last question. I think then it's.
So actually, I want to ask the reverse question of Andy Pollock. In Brazil, I'm from Brazil, we also don't have this structured data center for astronomy. I mean, we don't even have a space program for scientific satellites. But for the ground-based data, we have no organized structure. But discussions like what we are having here and initiatives like the Open Universe are actually helping us to get around and organize ourselves towards creating such structures in the country. So my question to you is, what's the impact of these kinds of initiatives in Russia on helping Russia organize its scientific data on astronomy?
I would say that because of lack of funding, the impact is purely inspiring people to do what they can do. But it cannot provide the new structures that require funding. You can change structure of the work of some people who, as Pepe said, we would work on this matter in any case because it's our job, but we are thinking about, say, virtual observatory, so we are moving in that direction. But you cannot create a new structure without funding. I think so.
Okay, thank you very much.